So how are you guys? How was the week? Oh, it's hectic. My laptop is always proper till I come here and start acting here. So is the last minute here? Are there any doubts that you would like to ask? Okay. Any? Okay, talk, you guys can talk. If you guys are angry with me, what? Huh? I don't know what is this no sound. What happened? Somebody died or something? You sure? Maybe it's dead. Okay. Why so serious? Something went wrong. Somebody scolded you. Everything is chill, no? No problem with me. Right? And then, fine. So, did you guys see the picture I put up in the group? Can anybody tell me what that is? Google, no problem. It's called Einstein. Yeah. It's called Newton's ring. Predicted by Albert Einstein. So the space, the light is one point in the direction has to be pointed. Okay. So the light is. Okay, good. Okay, you guys now keep quiet. Okay, you contribute something. You contribute something. Let's see. You can say I don't know, man. Huh? Okay. So what you're going to do is you're going to listen to 4 answers and then you're going to make up some answer and do that. Then any clue? If you didn't check it out, you can tell me. I don't know. You can guess also. You can give me a wrong guess. Huh? You're talking about the wrong guess. No, I put a picture of it. Are you in the group? You're in. Yeah. You're in the group. No, you saw the ring thing. Okay. Keep your phone on. Only some other persons in this group, you know. In which way we'll move back in the. We're going to go to the next unit, but I thought before that I'll show you something fun. And the image of the fun thing. So what happens is, let's say there is a galaxy out here. Okay. Which galaxy are we in? What is our galaxy called? Milky Way galaxy. And each galaxy has many number of stars, like our sun. And each star may have multiple planets. Okay. Or let us say the galaxy is our here. Okay. This is our galaxy. It's an ugly one, I know, but it is our galaxy. There's some galaxy. And there is one star or something, some other celestial body are here. Let's say. Or I think there is some galaxy here. There is some star that is a bird. There's a star or some planet or something here. And this is our Earth. Okay. Let us say on Earth, this is the human eye. Somebody is watching through the telescope. Right? Light will come from this far object. it will move in this direction, let us say. Okay, it will move in that direction. But because of the effect of gravity, sometimes gravity is so strong that it can bend, right? And in the case of black holes, you might have heard that gravity is so strong that light cannot escape. Okay? Gravity can even bend like this. This is not in a motion, but right? This is something interesting that happens. So what happens is the light is going like this because of the space time. Okay, don't worry about it. Just because of the gravity, it bends, it comes like this instead, and it goes to human. Understood? And what we do is human eyes, we always perceive in a straight line. So it doesn't matter how it is bending and coming. You must have gone through those things, right? Where in the wall there are multiple mirrors. Even if the light is going like this, if I see from that direction, I will believe that object is there. That is how we see this. So the human eye will be, we believe that the object is here, or it is here. And what ends up happening is the light goes in all directions as a cone, and it bends and it comes to the eye. So what the guy ends up seeing is a ring. Okay? Is that clear? Now when you see the image, does that make sense? You didn't even see the image of knowledge. Okay. Are you guys sleeping? Okay. What is the name of our group? So, this is what ends up happening. We see a ring. Okay. There's a star in the middle or something heavy, which is bending the light from a galaxy or something behind it. And the human eye sees in a straight line. What do you see? You see light coming from up, down, and that happens as circular way. Light is coming like this, right? Light will not only go from up and down, it will go in all directions. Understood? Okay, clear? Not in your question, you can read about it. It's called gravitational lensing, or these are also called Einstein's rings or Newton's. Einstein's. Right, another concept. Newton's. Right. Alright. So today we are going to look into this chapter called electricity. Okay, you guys know what electricity is. Okay, that is correct. But good one. Right. So close the textbooks. Close. Okay. So do you guys know the structure of an atom? You guys know the structure of an atom? So on the center, what do we have? We have the nucleus, and around the nucleus, what do you have? But what is on the shell? Electrons. Correct. So is there electrons that are going around the nucleus? So these electrons, what is their charge? Is it positive or negative? Electrons is negative. Electrons are negative. Okay. Neutrons are neutral. That's why they call neutrons. In the neutrons are the components that make up the nucleus. There are two types of neutrons. I mean, sorry, not two types. The nucleus is made up of neutrons and protons. Protons are positive, neutrons are neutral. Okay, understood? Electrons are negative. Now, these electrons, when they are excited, they can come. Generally, what happens is, see, this is a very simple diagram, but this could be a hydrogen atom. But for something slightly more complicated, generally, we have more number of electrons around it. The electrons which are present in our outermost shell, we can get excited and we can come out of the shell itself. And this will then become something called a free electron. Okay. So the study of the properties of this electron in any kind of situation is called electronics. Your electronics comes from that. Okay. The study of nucleus is called nuclear physics. It's as simple as that. And during any kind of excitation or de-excitation, it will give out energy. The study of that is light physics or photonics. Okay. Simple. Right. Now, in the case of so what happens is for my electron to come out of the outermost shell, I must give some energy. This energy can be in the form of heat also, it can be in the form of energy. Okay. It can be in the form of light as well. But there are certain materials, see, it depends on material to material. In some material, it is very easy to get the electron out. It's very easy to loosen those electrons. So much so that the energy that is required to loosen the electrons is so low that even at room temperature, already free electrons are available. Meaning that the energy that was required is so low that even some little bit of temperature is enough, and at your room temperature, already you have free electrons. They're available. Understood? Such materials where free electrons are available, they are called conductors. Generally, your metals. Okay? Your iron, copper, and those kinds of things. They have free electrons available. The moment, okay. So they have free electrons available. This is that. And now what I will do is, I want these electrons to flow from one place to another. Okay? And the flow of this electrons is called nothing but current. Okay? Is that much clear to you? That much is clear to you, right? Just like our rivers and all, they have a current flow. Similarly, our charges, they can move in a particular direction. We call it current. So initially, what happened was, when people discovered the flow of current, they did not realize what the charge is. They did not know that. They just found, okay, something is happening. I'm able to connect it. My light is glowing. Understood? They did not know if it is negative or positive. Those things they did not know. So they assumed that the charge which is passing through, it is positive in nature. They assumed. Are you understanding this much? It is wrong, but they assume, they did not know. So if I take a battery, you see my battery of this type, 9 volt or something. This is my positive and this is my negative. And I put a wire. Actually, how electron is flowing? Electron is negative. Electrons are negative. So they flow from negative to positive. Understood? Clear? So the electrons actually go in this direction. Is this much clear to you? But the people who studied this first, they did not know. They thought it goes from positive to negative. So they said that the direction of the current is in this direction. I have drawn 2 arrows. Okay. Alright. So this was there. The double arrow is there. First assumption, which is wrong. But since by then this idea was so popular, we have let it be that way. Okay. We still say that the current passes from positive to the negative. But we say the flow of electron is from negative to positive. So we say that the direction in which the current flows is opposite to the direction on which the electron flows. Clear? Simple. Okay, quite fundamental. Alright. You understand this? Or are you sleepy? Or are you hungry? Sleepy. Okay. We come to, is this concept is clear, right? Fine. Now, how do we define current? I define current as the amount of charge that is passing per unit time. It's quite simple. Charges are means the number of electrons, you would say almost. Alright. The next charge, the total charge, each electron will have some amount of charge. The next charge that is passing per unit time. Is that clear? It's quite simple. You can even write this. electricity. And the SI unit of this charge Q is called 1 coulomb. It's named after a scientist. And this will be second. Alright. This is my current. What is this? T. T. The alphabet T. T for T. T for tender coconut.
So I
represents current. Okay? Not electricity. They are two different. Current. Charge per unit time. Charge is what? The charge carried by an electron. It carries some value. I'm sure. I can't just say electron is negative. How negative is it? Has some finite quantity. So generally we can say n cube, meaning n is the number of electrons into p, the charge of one electron. We do these kinds of things and may not be important for your just remember the charge per unit time. Meaning in this one, in 1 second, how many charges are passed through? If I take one wire here, okay, I am connected one battery or whatever, and charges are electrons are there, okay, and they are going in this particular direction. My idea is, and there's another wire. This is, let's say, this for this one, we call this wire 2. Okay, this is the case. Now, are here 4 electrons, are here 2 electrons. So in 1 second, I put a stopwatch here, or I just want to see at this point, or let's say, okay, per unit time, in 1 second, 1 second, how many electrons are moving? So are here 4 move, are here 2 move. Where is the current move? That is the idea. So here the amount of charge will be more in per unit time in 1 second, more number of electrons or the charge which is passing is more, so the current is more. Understood? Concept is clear? And this, the SI unit of this is called coulomb, this is called second, this second. But so the SI unit for current should be coulomb per second, but we do not use that. We use another value, we call it ampere. Okay? Remember this. This is some basic stuff. The SI unit of this becomes ampere. Alright? Good enough? Named after a French scientist. So how do we define 1 ampere of current? 1 ampere of current, I can define it as, it is a situation wherein 1 coulomb of charge passes through a material in 1 second. That's my 1 ampere of current. Is that much clear? All good? Right. And to measure my current, I have a device which is called ammeter. I know terms, a lot of things you're learning in a very short period of time. But this is how it's going to be in the future. You have to grasp it. The main thing is you have to understand. Grasping is different. Grasping as in I'm not expecting you to remember everything, but I expect you to understand what I'm saying. If you understand it, you go back and you read your textbook, you don't know it. You just be able to remember it. Okay? Right. Is this much clear? Okay. Okay, so RAM around 8 GBs. And so based on this equation, we are going to do one problem right now. So can you note it down? Okay. The current, a current of 0.5 ampere. Instead of ampere, you can just write A, okay? The alphabet A. the current of 0.5 A or ampere is drawn by a filament of an electric bulb for 10 minutes. Okay, and repeat. The current of 0.5 ampere is drawn by a filament of an electric bulb for 10 minutes. Find the amount of electric charge that flows through the circuit. Can you solve this using this equation? First, straightforward.
I plan the solution. And the
What is the answer? 5? Hmm? 5? Coulomb. Wrong. Wrong. Why do you think it's wrong? Repeat the question to me after me. Can you tell me the question?
Current of 0.5
Listen, everybody carefully. Current of
0.5
okay, ampere.
drawn by a filament of an electric bulb for 10 minutes.
For
10 minutes.
10
10 minutes.
minutes. You know how to convert many to seconds? You just multiply to 60. You know when you guys are done, I know you are done. Huh? What is the P value? What did you get the P value? Huh? You have to do when I tell you. Okay. Fine. So this is clear for you all, no? Okay, move on. Something I don't want to do. So you guys understood the concept of current? You know what is charge? You know time, obviously, everybody knows time. Fine. So now we are going to look into something called electric potential. Have you heard of electric potential or potential difference? So what happens is water flows from a low ground to high ground or high ground to low ground.
Low ground to high ground.
The water in the house you
Water, okay, water.
high up or what?
High ground.
It flows from high to low because there is some kind of a difference, correct? There's some sort of a difference, and under the influence of gravity, it goes from high to low. Fine. When there is high pressure somewhere in your pressure cooker, inside the cooker the pressure is high, and outside the cooker the pressure is low. So, do you see the pressure going from inside the cooker to outside or from outside to inside? Inside to outside. From something high, it is going to something which is low because there is a difference. Okay. So generally the idea is that when there's an idea, okay. So the idea is that they try to get to something called equilibrium, like they try to mix up. We want the quantity to be normalized. If somewhere the pressure is very high, somewhere it is low, it will try to make it balanced. That is the idea. It wants it to be balanced. That is the law of nature. Anywhere, in anything we do. Here if I take a rod, here if I heat it up very much, here it is cold. Okay, what will it try to do? The heat will try to pass to the cold area so that the temperature becomes somewhat balanced everywhere. Okay, so everything in nature is like that, that it wants to come to something, it wants to balance things. Okay, and similar situation happens in our electricity car case, electric current and electric charges car case. And that is one of the most beautiful things, because what I can do is, now if I know that in this way the charge is going to behave, I can manipulate it. I'll show you how. I'll explain you what I mean. So what I do is, I take a particular material and I do something so that the number of charges now here is incredibly high. Okay, getting? The charges are very high. It's not only 9. I'm stopping like, let's say, millions of charges in this. Here, barely maybe, let's say 1 electron, or it's positive. Barely anything is there. So the moment I connect these two, what will happen? The electrons are here, will start rushing to the other end because they want to balance out the numbers. They want it to be balanced. Are you understanding the point? Because the concentration of electrons is very high here and it is incredibly low here. So it will try to immediately try to balance things out. Okay, it will try to average things out. Have you experienced that thing where if you touch something metallic sometimes during cold time, you get a shock? Has that happened to you guys? Have you seen in movies and all? You don't know? You hold something cold, tap or something, you touch it sometimes, you get a shock suddenly. Okay, so what happens at that time? So that is a metal. Usually, the metal has large number of electrons, charges. Generally, during the cold or something like that, because of some reason, you may have high number of positive charges. The difference is very big. The moment you touch these electrons from the metal, it will try to jump into your body, and it comes. The number of electrons is very high per unit time. It's coming like anything, and that's why you get a shock. Okay, so they call it static and all of that. Okay. So you have understood this thing. So you understood the concept of this difference, right? So the negative is very high here. This is quite positive or whatever. Positive means it need not always be positive. It may be that the negative is higher here. Related to this is low. Understand the difference? I'm only bothered about the difference. Maybe here also electrons are there, but the number of electrons are low when compared to this. Okay. So this difference is called potential difference. Okay. This difference is called, repeat after me, difference is called potential difference. Yeah. So where do we use, so greater the potential difference, no? Okay. Fine. You understood the idea of potential difference. Greater the potential difference, okay? My current is going to be greater. The number of charges per unit time is greater. See, you remember what is current? Charge per unit time. So if my potential difference is more, the difference is very high. This will try to go to the other side like very fast. Large number of charges should try to go there to the other side very fast. Okay. So the number of charges which are going per unit time is going to be very high, and my current is going to be higher. Okay. Just remember this concept and keep it on the side. As everybody understood this, I need a response. Otherwise, I cannot continue the class. I'm not able to understand. You got it, you didn't get it, I don't know. Did you get it? You guys got it? You understood? Okay, good. I'll do a test for you, especially. Better. Fine. So this concept of potential difference, I'm going to manipulate it. And what I will do is I will create a device in which one side is highly negative and the other side is highly positive. So the difference is very large. So that any time I connect two wires across it, I get a current. This device is called a battery or a cell. Understood? Fine. Now you are getting. Now it is something is flashing. Okay. This much is clear to you? So there is an equation for potential difference also. V is given by, okay, fine. Work done per unit charge, W by Q. Okay? Work done per unit charge. Okay? Don't worry about what is work done now. Just understand that if the voltage is very high, the charge is going really fast. So you could say that the work that the charge is doing or is being done on the charge is very high. Understood? Simple. The charge is moving very fast. You could say that the work being done on the charge is very high. So work done per unit charge. Clear? And the second unit of this is going to be our joules. Very nice. What is charge? We talked about this. This is going to be our volts. All right. Okay. So there's no problem based on this. Right. This is done. Write down the question. How much work is done? How much work is done in moving a charge? I repeat. How much work is done in moving a charge of 2 coulomb across 2 points? How much work is done in moving a charge of 2 coulomb of 2C across 2 points having a potential difference 12 volts? Across 2 points having a potential difference of 12 volts. Before what? Before 24 joules. Potential difference of 12 volts. Here, from now on, if you have gotten the answer, don't tell me the answer is given and okay. Joules formula, the formula of the code is for split power. I think it's very direct. V is equal to W by C. Work done by charge. So can you write the values for me? Can you put it please? V is equal to W by C. All right, on the side. V is equal to can you substitute the values? Well, I'm not going to right? Okay. Yes. Okay, so are we clear with the concept of current? Everybody knows what current is? Yeah. Are you clear with the concept of potential difference? Everybody is clear, right? There's no doubt about it. Right. So after doing this very simple thing, I will first jump into something called Ohm's law or resistance concept. Okay, Ohm's law. But remember this, keep this in your mind, okay? Or keep this on your book, write it down. Maybe you can, I can write this search here. Okay. Alright. Right. So there are a few. So now the thing is that, let's say you are an inventor, or you are somebody who works in the electrical field, you are an electrical engineer, or anything. Now you are designing a circuit to make something. Circuit means, okay, I want one battery, you will connect it to a light bulb. So how do you say this to somebody? You can say this like this also. Take one battery, connect it to a light bulb. But we have a standardized way of displaying things. Okay, and for that we use something called circuit diagrams. Okay, so instead of telling, yes. So what I do is I draw this figure. Okay, bulb and then put a round around it. So here the idea is this is my cell. Okay, for drawing a cell, I will draw it. This is a schematic representation. It's a drawing to explain. So this is your cell, and the longer side represents positive. Okay, the shorter side represents negative. Okay, so from where electrons are going, negative to positive. But where is current flowing? Negative. All clear? So for this, whenever you draw the direction of the current, I'm going to draw it from positive to negative. Understood? By default, I'm going to draw the direction of the current. The direction of the electron is understood that it is upward. Okay? Yeah. So this is my representation of a cell. This is my representation of a bulb. Okay? Right? Now, if I have multiple cells, I want to increase the potential difference. What I do is I increase the number of cells, and it is one like this. You can just okay, or you can draw it a number of times. Okay, is that clear? Is that good? Some people even like to connect. That depends on you. Okay. So it does not mean that I have 3 cells. It just means I have a battery. Understood? You don't have to draw 3, 4 exact numbers from it. It just means okay, there's a battery of that. That is right. That clear to you? Any doubt? No. So then, if I have a switch, now I want to add a switch to the circuit. What I do is I draw this. It's called a key. Okay, it's called a key. So here the key is not connected. The switch is not connected. Basically, switch is open. So can current pass through? It is not passing through. It's open. Now I want to close it. Meaning I want to turn it on. So I draw dot. These are 2 different things. So this means it's called a key. Okay, not a switch. Switch is slightly different, but you understand. No key like that. How you have buttons. Once you press it is on. Once you press it is off. So this one is open, it is off. If I want to show a closed key or a closed switch, I'm going to just put a dot in the middle. That's all it is. Okay. If I have something slightly more complex, from here it is going somewhere else. Okay. Again, let's say. So I'll just extend the drawing like this. This part, this area is my joint. It's called my joint. What is it called? Joint. Understood? Yeah. Then if I have something, okay, I can, do you know what this is? Huh? You can give me a wrong list. Be wrong, man, it's okay. Huh? No, wavelength is different things of wavelengths. Huh? What? Current. It's a device. Current is what? Current is something when charges are flowing. These are devices that are running on that. Understood? They are two different things. Current is going inside of this thing. The symbols are using, they are devices that run on current. Okay? It's like if there's a fridge, washing machine, things like that. Current is going through it. Current is not another device, it's not something. Understood? No? Okay? This is called a resistor. Okay? Resistor. We will look into what is resistors in a while. Just remember, this is a resistor. Okay? And current, very interesting question. Very good question. Like this, it sounds very stupid also. But if somebody was studied it, I could actually say it's something. Okay? I like that question. Okay. Resistor is it adds resistance to the current. Okay, flow of charges. That's a resistor. As simple as that. And though I may have a okay, we are continuing. The question was good. You got your 2 minutes of fame.
No, I asked you from that Spider-Man character. I like from Bewitched Blue.
Okay, very good. Now we'll continue. We will talk about this another time. Okay? Fine. So what is this? What does it do? You are here or you are with the electrode? You are electrode. So it resists the flow of current. Okay? How much resistance I want, I can add it. Why? We'll look at it in a while. Okay? Fine. I may also have a device which is like this. If this is the sign, this is called a variable resistance. Means I can change the resistance. That's all. Okay? Resistance can be changed. More resistance to current, less resistance to current. I know this is too much to kind of maybe take, but you just get the general idea and what are the symbols and what it stands for. You can check it out in the textbook. There is drawn a table. Okay? Fine. Then we have a device called ammeter. What is an ammeter? We talked about ammeter. I mentioned ammeter before. It is a device which is used to measure the current. Okay? Measuring the current. And I may have another V, which is called voltmeter, to measure the voltmeter. What does it measure? Voltage. Okay? So we'll go quick revision. This is my cell. This is my battery. This is going to be my, is it on or off? On. On. Dot means it is going through. Okay, some connection is there. No dot means it's off. Okay. So this is without the arrow. This is going to be my. What does it do? The flow of current. What is this?
Variable.
Resistor variable resistor. I can change how much resistor. Okay. This is my ammeter. Ammeter is called ammeter. Okay. It measures the current. It measures the current. This is my voltmeter. What does it measure? Voltage. Awesome. Very good. This is also called the joint. Uncles and aunties, they have joint pain. Remember it. Okay, so this much is clear. Okay, now we are going to see something very interesting, which you will throughout if you are going to do, okay, in 11th and 12th, they'll bug you with this, and this will keep following you for a while. If you're going to do engineering, in first year engineering also this will follow you. If you do BSc also this will follow you in the first year BSc. This will follow you everywhere because it is one of the most fundamental laws of physics, and you can call it one of the first proper laws in physics in what, electronics as well. Okay. So this law was discovered by this fellow whose name was Ohm, not Owen, not it's not our Indian one. That was his surname, Ohm. Okay, whatever. Like what kind of name was this? Okay, fine. So, and what he did was he conducted an experiment, and he said, you know what? It's very simple actually. You could say that he took a wire, okay, and he connected. This is the wire, okay. He connected a power supply. Generally, you could draw a cell or a battery for this, but I'm going to draw. This generally means okay, DC current, but okay, just imagine I'll write power supply for in there. I don't confuse you. That's not that for you, so let's not talk about power supply. This is one wire. And what he's saying is he wanted to see, and across this power supply, he put one voltmeter. What does a voltmeter measure? Voltage. And now here we put one ammeter. And what does the ammeter measure? Current. Amazing. Somebody said it measures power supply. Okay. So what he did was she said, okay, I'm going to take a graph. This is my x-axis, my y-axis.
So is it a he or a she?
The he. If it was she, you would be more interested.
Oh, no.
Okay. So he just back to this. He plotted a graph. This is his x-axis, that's his y-axis. He said, I'm going to increase the voltage up here, and I'm going to see as the voltage changes. I can see from here, right? How much voltage? How is the current changing? Okay. So let's say he increased, and this is going to be my I. I is what? Current. V is what? Voltage. Good. So first he put it at 5 volt. Okay. And he noted that I at 5 volt, the current which was measured was 5 ampere. Okay. This is going to be 5K, or in the bracket here I can write ampere. That is the unit. Okay. Always when we are plotting a graph, we write what we are measuring, and in the bracket we are writing the unit. Okay. I hope you guys know about this. P bracket volts. Okay. Fine. Then he measured it at 10, let's say, and he found out that surprisingly, here also the current was increasing till by 10. So for the range of values, he kept on increasing the voltage, the power supply, he kept on increasing the power supply voltage. The voltage across it increased and the current also increased. So this was the trend. Okay. You're getting it? The trend, as this was increasing, that was also increasing. So this was the Ohm's law. That as the voltage across any particular conductor it increases, the current also increases, provided temperature is constant. Generally, we put that. I don't know if that is the law for you also says that. Okay. Yeah. Okay. So the idea is basically V is directly proportional or inversely proportional to I. Is this correct? Or is this correct? Okay, it's very slant. V you know what these things are? You know what it means, right? Is it right? Which is correct? You're saying this cannot be correct. Why? Okay.
It's direct.
First one, maybe. Okay. She said maybe, so now first one. What do you say? Need to guess. You know what this is?
I got the child complex.
Okay. No, that's fine. The idea of proportionality is that when something increases on this side now, this also increases by the same amount. Okay. So if I say Lanish eats a lot of food proportional to Lanish gains a lot of weight. The more Lanish eats, the more he gains. That's nice. Okay, so alpha is proportional. Idea? You got the idea? Fine. But there are some people, the more they eat, it's inversely proportional. The less they gain. So if this increases, this the value of W decreases. Okay. So here is it increasing with current or is it decreasing? So is it directly proportional or inversely proportional? So the thing is, this proportionality only means when something is increasing, the other quantity is increasing, but it does not tell us by how much. Meaning, I cannot use this as an equation. I cannot say, oh, 5 proportional to 5. It's not equal to, you're getting it, 5 is not equal to 5. There is an increase. I have written to you that, okay, 5 increase, 5 increase are here. It may have been that there was a steady increase, but it was not equal. At 5, maybe it increased by 3. Okay. At 10, it increased till 7 or something like that. There was some increase, it came something like this. You're getting it? It is increasing, but it may not increase by the same amount. Are you getting the idea? Just because I eat 5 kg of food does not mean I gain 5 kg of weight. I will gain, but it may not be equal. Okay? So is it equal to this? No. It only means when this is increasing, the other quantity is also increasing. By how much we do not know. So whenever you have to equate these two, you put a constant. And here our constant is called R. Okay? Is that clear to you? So the idea is, if this increases by 5, the constant is going to have one constant value that will multiply and it will tell me by how much it is increasing. Are you making sense of this? Are you clear with it? So if I eat 5 kg of food, I may not gain 5 kg, I may gain 2.5 kg. Okay? So what does that mean? 5 kg I have eaten, I have gained the constant times 2.5. So what is the value of my constant? What is the value of R? 2 is my constant. That means this is a property of my body. How much it can digest and how much it is gaining. So now, if I eat 10 kg of food, how much will I gain? This constant remains constant. How much will I gain? Huh? Correct, 5. I gain 5 kg. If I eat 20 kg of food, how much will I gain? I get 10 kg. So this is a property of my body that every time I eat something, it divides it by 2 and that is the quantity I gain. You getting it? So it is because of the constant that the equation makes sense. Understood? Otherwise, in proportionality, we only know this is increased, that one is increasing. By how much? We don't know. Clear?
So R is honest.
No, for me.
Oh,
In this case, this is an example. Okay? Fine. No, good question. Good question. we should ask questions. It's good. Okay. So here, this particular R happens to be a very important quantity. This quantity is called resistance. Okay. So that means that voltage is increasing, current is also increasing. But there is something that is coming out here which is defined by how much it will increase. It's like a tap which will control the flow. Understood? Ideally, it should increase, but there is some controller in between which will regulate this increase. What is that controller? It's a resistance, and that resistance is the constant value for a particular material. For gold, the resistance is going to be the same everywhere around the world. For copper, it is going to be the same everywhere around the world. But the resistance of gold is not going to be equal to the resistance of copper. Understood? It is a material property specific to that material. Is this much clear to you all? Okay. So then can I write that my R is equal to V by I? Is this, can I write it like this? Yes, this makes sense. And there was something that I wanted to tell you guys. So what we are seeing is, so okay, R is equal to V by I. So what is on the numerator of here? R. What is on the denominator of here? I. So is R directly proportional to I or inversely proportional to I? It's inversely proportional. Meaning when R increases, I decreases. Wonderful. So if the material has more resistance, the current is going to decrease. Awesome. So if I take another material with less resistance, the current passing through it will be more. So what can I do? I can play with a particular, I can play with charges. You want a phone, you want a mobile phone. Okay. I want to run a mobile phone. I know, okay, I can design the battery in such a way that it gives me so much voltage. Fine. But in your mobile phone, there is a camera or there is a torch. The torch does not need this much, the kind of current that this is giving, the power supply is giving. The torch wants less. So what will I attach to the torch? I will attach a resistor. It will reduce the current and the torch will work. Too much power supply, it may get spoiled. Understood? Is that clear? So can I play with these things to get my application? Is that making sense to you? Okay. So the power supply that we get generally, the voltage or anything you get is quite huge to the house. Then what do we do? How does the TV work? How does your mobile charge? See, on the same plug you put the TV and it works. TV is a very big device. But on the same plug, you're able to connect your mobile phone, which is such a small device. How come mobile is not exploding? Why? Because it has a charger, it has an adapter. That adapter has some resistance. It will lower the value that the mobile can charge without getting spoiled. Are you clear with this concept? That is why even the common point I can use this thing and I can use big load devices. I can use devices which consume a lot, fridge, AC. And on the same thing I can maybe generally I can put even a mobile phone for charge. The adapter, the charger will take care of the rest. Are we clear about these concepts? Yes. So do you know so I'll write this up. I think you can erase this. R is equal to V by I. What was the SI unit of V? Volts. What is RI? 1. So the reason I'm asking you again and again is I want to remember these things. Okay, it becomes easier for you. But the SI unit of our resistance is given is named after the scientist. Okay. You say 5 ohms, 10 ohms, 10 ohms. Sounds funny, I know. Alright. So with this, shall we conclude today's class? Is that fine? You guys understand things? Clear, right? But see, from next class, I want you guys to talk to me. You don't tell me anything, I don't know what is happening. I don't know, you guys are confused. Is it me? Is it you? Is the weather bad? Is it the AC? Did previous teacher say something? Did somebody scold you? I have no idea because everybody is quiet. You guys talk to me. And then I think maybe, okay, I'm not teaching properly, you guys are not understanding. Okay? So I need to know. Fine. With this, we will wind up today's class, go through it, go through the textbook, and understand these things. Okay? And in the see what we have done previously, previous class stuff, I want you to go through that. Remember those formulae, study those formulae, do that because if others will forget it. Okay? Have they announced something about a test or anything? They told you? They told it on Saturday. On the first unit, right? First chapter. Don't study last moment and come. The test might be difficult. Okay?
Write the hashtag.
Huh?
Write the hashtag.
What is that? That's only tying half the hair on the top, right? You only got some hair on the line.
Oh, that's small, yeah.
Yeah, sir. It will like,
I
what do you have to talk? I don't know that they decide. I can talk to them. I'm not sure. It might be slightly difficult to study and you should know your concept well. Okay? Just don't think if I read it once and I come, it will be easy for me. We might have done some beginner level problems and all of that in class because just now when I'm teaching you concept, I cannot give you tough problems. I have to start with the easy ones. Right? Today's also problems for direct substitution. But my point is, if you understand the concept, even if you go through a difficult problem once, you will know how to do it. Because you have understood the concept. Concept remains the same. But for that, you have to go through the difficult problems. Okay? It need not be taught. What has to be taught is the concept. If you don't know the concept, you cannot do anything. Nothing you can do. You are absolutely zero. If you know the concept, you go through something, you can understand. Okay? Yeah. No. Take care. Okay, yeah. If you have any doubts, see the WhatsApp group, you can put your doubts up or there and all of that.